I've been asked to talk about inequalities and how these are shown on a number line. And I'm going to race through a whole bunch of different things here. So let's just see how we go. First of all, let's talk about integers. So that's basically the x is going to be some kind of integer. So let's do integers first. Integers, when expressed on a number line, are always just a dot. And as a dot, they're going to go from one place to another. So, for example, I might do it like this. Just have 2. In this case, when I've got something like this, I always write the lowest one to the left. Here's the lowest one is a -2. So I've got a -2. Put an x in the middle. And I've got an upper one here, which is a -1. And we know in this case that x is going to be an integer. So I might write x is an element of integers. Right, so x in this case is going to be equal to 2, and it's also going to be equal to -1, equal to -2, and equal to -1. So x is going to have to be on between this one and this one. So we're going to write equal or greater than -2, and equal or less than -1. And we always write it in this fashion here. So it's always, the signs are always going the same way. Let's spread it out a little bit further. Let's go -3. This time I'm actually writing it on the line, yeah? Up to 2, yeah? Here it is. And I'm going to write -3 is the low one, less than or equal to x. And this is going up to 2, which is less than, so that's x is greater or equal to -3, and all the way up to 2. Of course, x is an integer. All right. What about something else? What about, let's say it's a whole range of them. Let's say, oh, by the way, sorry, I would have had to have filled all these in as well. It can't just be those 2. So you have to write each point in. And these are discrete points, which means they're individual points. Point, yeah? Point after another. Okay, so let's say, for example, we wanted to say x was in a certain range and just kept on going. So let's say, for example, you've got 2, 3, 4, 5, and so on, all the way up. We'd write 3 points at least. We could write more, and then we just draw an arrow in the direction that it's going to be. So in other words, x now is going to be, at the lowest it's going to be is a 2, and it's going to be greater or equal to 2, and it's going to be going all the way up and beyond that. So we could write it like this, but then we run out of things to write. What do we write here? Because it doesn't end at 5, or even 6, or even 7. So we're not going to write it like this. We're going to change the way we write this and just say x is equal or greater than 2. So once we've got a continuous line, a line that keeps on going, we change it and we write it like this. X is greater or equal to 2, and obviously it's an integer. So we write it in this fashion. Same on the other side. Let's say it was going to head downwards, and let's say it was going to be -2, and I'll write them above this time, -3, -4, and so on, all the way down, and just keeps on going. I've got my arrow, so x is going to be from -2 all the way down. So x is going to be less than or equal now to -2. And of course, x is going to be an integer. So that's how we would write those. Now, we don't write open circles usually for integers. It would be a little bit unusual. It would be a little bit unusual because that's reserved for well, real numbers, basically. Well, let's look at some real numbers now. Hopefully, by the way, those things make sense. Let's do some real numbers. Let's this time say we're going to go from, well, let's start going from 3 all the way up. Yes, so it's going to be from 3, and it's going to be 3 all the way up forever. So we're going to say x is equal or greater than 3. It's going to be including this dot and everything else higher. So it's got to be equal to 3 and greater than 3, and x obviously is a real number. Well, what say it doesn't include 3? It's going to be everything just above 3, but not including 3. So it might be like 3.1, 3.2, 3.3, 3.4, and so on. So it's going to be everything above, just above 3 and beyond there. So now x is going to be greater than 3. Can't be equal to 3 because it never quite gets down as far as 3. It gets down as far as 3.00001, 3.0000002, 3, and so on. Yeah, you get the idea. And of course, x is going to be a real number. Well, what about going the other way as well? Let's say we're going to go from 6 all the way down, including 6. Here it goes. So x is now going to be less than and equal to 6. Less than and equal to 6. So it includes 6, but it's less than as well. So it's going to be all the numbers all the way down. Yeah? Now, what say it was going to be 6, but not quite 6. It was something like right up to 6, but not including 6. Like it might be 5.999999 and so on all the way. We write a circle. So it never gets to 6, but it's going to be everything less than as well. So now we're going to say x is less than 6, and of course, it's a real number. All right, let's try some other ones. What about if it was a range of numbers? Or what about down here? Let's say it was going to be -2 all the way up. So here it's going to be not including -2, but just almost down as far as -2 and everything above. So it would be x is going to be greater than -2. Let's say it was including -2. Here it is. Now x is going to be greater than and equal to -2. Oh, sorry, -2. There it is, negative. And x, of course, is a real number. All right, what about going the other way? What about the range going down? What say we wanted -4 and forever? And we're going to include -4. There, including -4 all the way down. There it is. So x now is going to be less than and equal to -4. Put the negative in there. And of course, it's going to be a real number. Of course, what say we wanted to do it differently? What say we want to say -5 and all the way down, but not quite -5. Nearly -5, but everything below, not including -5, everything below -5. We would write it like that. So x is going to be less than -5, and x, of course, is a real number. All right, well, let's do some ranges now, a range of numbers. Well, let's say we're going to go from -4, and we're going to go all the way up, including up to 1. So I'm going to write those two things down. So it's going to be -4 and 1, and I'm going to put an x in the middle. Now it's going to be equal to -4 and equal to 1. So it's going to be greater than -4 and equal to, but equal to -4 as well. So it's going to be, here we go. So it's going to be greater than -4 and equal to -4. And it's going to be equal to 1, but also less than 1. So the range is going from here to here, including those numbers, and we put a line in between showing it's everything else in between. Every single possible number, -3.5, -3.3, -2.5, 2.6, 2.7, -1.4, 1.5, 1.6, and everything, all those numbers in between, everything. And of course, x is a real number. All right, let's have a look up here now. What about, so we made it going from -1 all the way up to 5. Here we go. So I'm going to write the lowest one, -1. It's going to be up until, oh, you can't see that, sorry. Up until 5, all the way up to 5. put an x in the middle. Now it's going to include -1, so it's going to be x is going to be greater than -1, but equal to -1. And it's going to be less than and equal to 5. And of course, it's going to be a real number as well. All right, hopefully that makes sense. I haven't left myself much room here, sorry, to write this. Okay, and everything else in between. There it goes. What say we want it to go down as far as -2, but not touching -2, and all the way up to 3, but not quite getting to 3. In other words, we want it to be less than 3, but not quite getting to 3, greater than -2 and not quite getting to -2, and everything else in between. So we're going to say x. Now this time I'm going to leave out the real number stuff on the end there. Probably shouldn't technically, but I'm going to leave it out because I haven't got much room. So it's going to be -2, and at the other end I'm going to write a 3. X goes in the middle, and it's going to be, this time, it's going to be greater than -2. So x is greater than -2, there it is, and less than 3. And that's how I would write that. What say, let's do something a bit different now. Let's say it was going to be including -4, goes down all the way to -4, including -4, then goes all the way up to 5, but doesn't actually touch 5. It almost gets to 5, almost all the way, never quite gets there, and everything else in between. So x is going to be going down as far as -4. It's going to be equal to -4 and greater than -4. There it is. But it's going to be less than 5. It never quite reaches 5. So it's going to be less than 5. Let's try another one. Let's make it real short. Let's make it negative. Let's go from -5 and -4. It's going to be greater than -5 and less than -4, but never quite touches either. So it's all the things in between those, but not including -5 and -4. So we write the two hollow circles, put a line in between them, and at this end we're going to be saying -5 is the lowest, -4 is the highest, x is in between. It's going to be greater than -5, but never quite getting down to it, and it's going to be less than -4. All right, what say we wanted to go from, let's have a look here. There's some quite good what we could do here. What say we want to go from -5, but not quite touching -5, goes all the way down to almost -5, not touching, and goes all the way up to 1. And it does touch at 1. So it's between -5, but not quite touching -5, but all the way up to and stops at 1. So it does touch 1, nearly touches -5, but not quite. So now we're going to say a -5 and an x and a 1. So it's going to be greater than -5. Here we go. So x is greater than -5. And it's going to be equal and less than 1. All right, what about this one here? Let's go from, let's see. Let's go -6. I like -6. Let's go -6 all the way up to +6. And it's going to be in between there, but never quite touching those two. So here we go, in between there, never quite touching those two. And we're going to have -6 to 6. X is in the middle. It's going to be greater than this one and less than that one, greater than that one and less than that one. And that's the answer. Now, we also talked in class today about whole numbers. So we've got integers and we've got real numbers. Whole numbers, by the way, and they might ask you whole numbers in the exam. I don't know that they will, but mostly integers and real numbers is the general plan. But if they ask you whole numbers, thing is to remember, whole numbers are going to be similar to integers, but whole numbers, and I'll write this out here, whole numbers are an element of the set of numbers that are 0, 1, 2, 3, and so on. In other words, they're counting numbers including 0. So if we were to have whole numbers here for a moment, let's say I was to go from Let's actually draw a line here, and I'm going to represent this. So a whole number could include 0. So I could go here, 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 for example. So this is going to be going down as low as 0, including and equal to x, including and less than 3. And in this case, it could be, you could call those integers, but you could also say x is an element of whole numbers, w. Because the whole numbers include 0. They're just like integers, but they couldn't go down this way. All right, what about the other numbers we had? We had natural numbers. Natural numbers, same deal. But natural numbers are counting numbers. They're things you would see. Like you wouldn't see 0 sheep. You wouldn't see 0 chairs in a classroom. Yeah, it's not something you would observe. Something you could calculate, but you couldn't observe it naturally. Yeah. So let's say, so for example, these are not whole numbers. Sorry, these are whole numbers. They're not natural numbers. So you couldn't represent these as natural numbers on an inequality like this. But you could say these ones here we go, these 5 numbers here, these are natural numbers. So you could say we're going from 2 up till 6. X is a natural number, there it is. And we've got an x in the middle. It's going to equal and be greater than 2. And going to be less than and equal at the same time to 6 and everything else in between. And they are natural numbers. So it's a little bit unlikely that you're going to get that, but you could do. I wouldn't put it past them to give that to you, but that's something you might end up with. All right, well, I think we've pretty much covered all the bases there. Hopefully that makes sense, and if you've got any questions. By the way, great question to those who asked this. Very impressive. By the way, hopefully I've got all that right. It's entirely likely I've messed up somewhere. So I do apologize if I have. In the meantime, any questions, get back to me.